Hello, everybody. My name is TJ Willits from Veolia Water Technologies. Thanks for joining us for today's presentation. We're just going to give it another minute or two. Some people are still logging on, so I just want to allow them to get settled before we start today's broadcast. So thank you for your patience, and we'll start just momentarily. Hang tight. And I saw a couple more people sign on. Just want to let you know that we're going to be starting soon. We're just letting some people get settled here as they log in, and then we'll just start in about 30 seconds or about 60 seconds. All right, we're going to go ahead and get started with today's webinar. Today's webinar is entitled Preparing for Shutdowns and Maintenance Events. It's a really interesting webinar that's real practical, and we hope that everyone here finds a lot of value in attending today. So just some technical notes here. Obviously, you should be hearing me speak now. If you're having issues with your audio, there's two methods to connect to the audio. You could use your computer audio and listen through your headphones or speakers, or you could dial in. If you select phone call, you'll be able to use your phone to listen to the audio portion of today's webinar. We want this webinar to be as interactive as possible. We have some time near the end of the broadcast to do a question and answer session with today's panelists. But throughout the presentation, if you feel need to log your question, go ahead and do so in the questions panel on the right-hand side of your screen, and we'll try to get to as many of those questions as possible near the end. Just one other note, the webinar is being recorded, and if you are attending, or if you've one of your colleagues registered and they couldn't make it, they'll be sent a link to watch this webinar on demand when they have a few moments. In terms of, there's a survey that will be given to you right at the end of the webinar when you log off. Go ahead and fill that out. It's really important to do that, and as well as you can request a participation certificate, which will be sent to you a day or two after the webinar broadcast. But the one thing is, in that survey, there's a place to go ahead and issue some feedback on future events or topics that you want covered by our expert panelists. So transitioning to today's presentation, I'd like to introduce our panelists for today's topic. Our first panelist is Jill Jordan. She's a senior process specialist here at Veolia. Many of you probably have known and worked with her in the past. She's a great asset and has a lot of working experience on the topics that we're about to discuss today. And also joining us today, a first-time panelist for our webinar series is Jack Kuhar. He's the operations manager for this particular group within Veolia Water Technologies, and has a wealth of experience in design and execution of projects that include biological wastewater treatment. So without further ado, we're going to hop into our webinar, and I'd like to hand over the presentation to our first panelist, Jill Jordan. Jill, are you with us?
Yes, thank you, TJ, and hi, everyone. Thanks for coming on as everybody's busy and getting ready for the holidays, so I really appreciate that. Today's webinar, we're going to first do a little safety blitz, and then we're going to talk about shutdown and startups of your high-rate anaerobic reactors. And then Jack's going to talk about the specific maintenance items for the high-rate anaerobic reactors, which includes feed piping, settlers, and general gas handling equipment. As far as safety goes, I can't emphasize enough how important it is to follow basic safety rules, especially in these wastewater treatment plants where there's so many confined spaces. Not only you have a lot of tanks, you have wet wells, you have dry wells, you have sumps. They're all confined spaces, and these confined spaces, especially if they have anaerobic effluent running through them. You could have, or gas lines, you could have a very toxic environment in there. The biogas, as you know, it could be explosive. It's natural gas. So you have to, although you need three things to make it explode, which is the fuel, which is your methane, you need oxygen and a source of ignition. You usually only have one of those, but you got to be careful. You don't want to blow yourself up. And also the biogas contains hydrogen sulfide, which is very toxic. A lot of people don't realize that even the anaerobic effluent lines can contain biogas. So you have to be careful with working on those lines too. We also always recommend that you wear your H2S monitor so you know when you might have a biogas leak. Okay, so today's presentation is reactor system shutdown and best practices. So we're talking about high rate anaerobic systems that have granular sludge. So I want to go over a little bit about granular sludge and then how to shut down and start up these reactors. In these high rate anaerobic reactors, we have granular biomass. And it looks like this picture. It looks like little beads of caviar. And there's no carrier in them. They're all soft. They're just a ball of a mixture of acid and methane forming bacteria. The thing that's really neat about these is that they can go dormant for about a year and still work. In fact, this process, these high rate anaerobic digesters were first developed for the sugar beet industry in the Netherlands. And in those industries, these reactors work for 3 to 4 months a year during the sugar beet harvest, and then they sit dormant for 8 or 9 months, and then they're started up again. So it was really clear from the very beginning that this anaerobic bacteria, especially in this granular form, could be dormant and not have to be fed or cared for. So if we're going to shut down the system, we don't have to worry about not feeding it or anything, but there's some actions that need to be taken to make sure that the system is shut down properly. Let's put it that way. If the system's only going to be down for a couple of days, 2 to 3 days, there's no need to even shut anything down. I mean, in all of our systems, you could put the system in recycle mode and just start the system up again and reintroduce influent water as soon as it comes back. If you know you're only going to be down for 2 or 3 days. If you're going to be down for more than that, you want to shut the system down. And to do that, you want to shut off the influent flow. That is the influent flow coming from the plant or from the EQ tank that's going to your rapid mix tank or your conditioning tank. That's your influent flow. You want to stop that and put the system into 100% recycle. The rapid mix tank or conditioning tank pH adjustment system can also be shut down as soon as the pH set point has been reached. Also, you want to stop your nutrient addition. There's no need to add nutrients if you're not feeding anything. So once you're in recycle mode, you want to recycle for, I'll say 12 to 24 hours. Could be less than that, depending on your sludge and what you're digesting, your substrate. You really want to recycle until the gas production isn't measurable and the flare flame isn't visible, especially if you have an open flare. It's easy to tell when that happens. It's not so easy if you have a closed flare, but you get the picture. You can see on your trends when the gas production goes down to just about nothing. That means that all of the COD that's available has been eaten. And so you can safely shut down the reactor without worrying about pH control and things like that. The next thing you want to do is to shut down the reactor feed pumps and the ancillary equipment. I already talked about the pH, and you want to nutrients. So those are the things that you want to make sure aren't dosing anymore. The digester you really don't need to do anything about except for to isolate the tanks by closing all liquid piping at the valves at the tank interfaces. And you really want to make sure that that's the digester feed piping header valves are closed, because if you don't, it's likely that sludge can work its way back into the digester headers and cause them to be clogged. So that's really, really important that you close the digester feed header valves. The thing that you cannot and should not close are the gas piping valves, though, because even though you've digested, quote, all of the COD, there's always going to be some solids in there or some little bit of soluble COD that's going to continue to make gas even though you're shut down. And even when the system cools down, especially if you're going to shut down this time of year when it's cooler, and you all know from previous webinars that as the temperature goes down, the activity of the sludge goes down, you're still going to make gas even under those conditions. And you want to be able to discharge that gas in a safe manner. So you need to keep the biogas lines open and at least the lines open to the flare. And again, if you're going to shut down in this time of year, you can freeze. I can't tell you, I think in the 40 years that I've been doing this, every Christmas holiday, somebody calls that they have frozen a line because it wasn't heat traced or insulated properly, or something happened like that during this upcoming Christmas shutdown. So be really careful with that. Make sure that your heat trace is all on, and that everything, all the insulation is put back after you've torn it off for some reason during the year, so that the lines don't freeze when there's not warm water going through them. Really important thing to do. Okay, so now your system is shut down. Okay, so it's been shut down, we don't know for how long. So the first thing you want to do to get started again is to open all those water lines that you closed at the tank interface. And I want to say, I always say to close the valves at the tank interface because I don't want a truck to plow into some line and break it, and while nobody's there and you lose your whole tank volume. It could be an EQ tank or your digester or whatever. So that's why we say that. You're really isolating and protecting your tanks that way. So open all those water lines at the tank interfaces. Okay, now you're really ready to go. So the thing that you want to do now is to start up and recycle, and to get the pH, check the pH, make sure it's okay. And although I forgot to put it on these slides, you want to make sure you get your temperature up to the normal operating temperature again, if possible. So that's going to determine how soon before you want to start taking influent that you start to take, the system and recycle, because you want to get things heated up before you start up again. Now, the sludge has had a time to settle while you haven't been running, and it's going to get really, really thick at the bottom. So you want to manually mix the sludge bed. After you start taking some influent, you start to get some gas production. So give it a couple hours after you start your influent flow, and then do the mixing the sludge bed. And Jack's going to talk about how to do that later on, in case you guys have forgotten how to do that. And consistently check the sludge profile. You don't have to measure it, just take a sample and see if it's loosening up a bit. So for short-term shutdowns, 3 days to a week, once you shut down, get things started again, just start up where you left off. Start at the flows that you were operating at when you shut down. If you're down for more than a week, couple of weeks, you want to start up a little more slowly. So if you were taking 100 gallons per minute influent flow to begin with, you want to maybe try starting at 75% of that influent, 75 gallons per minute, which is 75% of where you were. Again, you got to pay close attention to getting the sludge moving again. And once you get the gas production up, that mixing will all be taken care of by the gas production. Check your VFAs. Maybe you want to check your VFAs like once a shift so that you can increase your influent flows as quickly as possible. And the VFAs are going to tell you whether you can do that. Now, if you're down for 2 to 6 weeks, again, similar to the last one, where you're starting at 75%, here you may want to start at 50% of the influent flow, or where you left off, 50% of the loading. Again, make sure that you get things moving and get the gas production up as soon as possible. If you're down for more than like 6 weeks, that's a long-term shutdown. You want to start up at a very, very low F to M. Forget about looking at your flows and your loading. Start at an F to M of like 0.1, maybe to 0.2. Depending on what your normal operating F to M is. And again, manually mix the sludge bed a couple times a day to make sure you're getting good distribution of the influent into the sludge bed so that you can get that gas production up as soon as possible. And again, do your VFAs, and as the VFAs tell you, and your gas production is good, your COD reductions are good, increase that loading as fast as you can by maybe 0.1, 0.05 kilograms of COD per kilogram of VSS per day until you get up to where you were. Okay, so I'm going to turn this over to Jack now for the key maintenance items that might be that you might want to take advantage of checking while you're down. Jack, you're on.
Okay, thanks, Jill. So I've been with Veolia for about 10 years, done a lot of design and installation of all these systems, but also done a lot of inspections working with clients when they are down to inspect their system. So I get to go in and see all the fun things that happen after many years of operation. So it's pretty interesting. So TJ, you can have the next slide. There you go. So main components inside your systems are the settlers. They're doing the three-phase separation, the gas, the liquid, the solids, and the feed distribution piping on the floor to distribute and mix the water coming into your tank. So those are usually the key components to be looking at when you're down and can go inside the tank. So we have a couple different types of reactors, open top and closed top. Starting with open top, you can typically take off covers over the settlers where the effluent's coming out of the settlers to see them during operation and clean them. So with these types of reactors, there's no risk in taking off these. There's no major risk in taking off these covers because the biogas is collected under the settler and under the deck of the tank, and it's not coming out under these removable covers unless there's a major failure of the settler. So what can happen over time is there's these weirs, they distribute the flow along the length of the settlers and meter the water out of the settlers. They can become clogged, or those troughs can become clogged. So you'll need to do some cleaning at some point during operation or during shutdown, and check the levelness of those weirs. So cleaning that, we recommend typically once or twice a year. Depending on the application, it could get pretty solid, a lot of solids up there. You might have to do it more than that, but it's kind of wastewater or industry specific. So, again, as we say, each reactor is different. So, yeah, and spots where we have more sulfur in the wastewater, calcium, you can get buildup of solids up at the top because in an open top reactor, you have anaerobic effluent with air. So you start producing some solids that kind of plate out or build up in that space where there's air and anaerobic effluent. So a lot of times if you have high sulfur concentrations in your, or sulfate concentrations in your wastewater, that converts to H2S, and you'll see, and if you take your covers off, you'll see this kind of like white and yellowish crust and solids building up underneath your covers, and that's pretty much the sulfur coming out.
Jack,
So
I just want to butt in here and say, be careful when you're cleaning these. You don't have to. Typically, it's pretty easy to clean them with just a hose and or a brush or a broom. You don't need to. Most of the time, you don't need to power wash them.
Correct, because most of the stuff is all fiberglass. So power washing it is gonna, high pressure is gonna damage the fiberglass if you try to put it like a typical power washer on it. So the other type of reactor is the closed top. So typically they do have the same type of settlers, but again, they're not easily accessible. They are completely enclosed, and the entire settler is enclosed in the biogas space. So there's less susceptibility for kind of solids build up due to the sulfur or the calcium because there's no oxygen in this environment, but you can still have clogging. So you can still build up solids in your reactors. Say your sludge bed gets too high, or you have floating sludge or something along those lines, your settlers can get clogged. It can clog the settlers themselves. It can clog the weirs. So see in this picture, there's typically a 42-inch manway on the top center of our tanks. So that's the way in for maintenance during an outage. So typically we have a viewport somewhere on the top of these closed top tanks. So if you're seeing issues with your performance, seeing solids loss, first idea is to go kind of look in the top, see what you can see. It's always very difficult to see in there because of, well, it's dark and sometimes you can't get good access to that viewport. But typically what I've been able to see is if I take a jacket and completely enclose myself around that viewport and look inside and have a nice strong flashlight, and you hide all the daylight away from it, you can see. So that's really the first way you can look and see if you have some kind of maintenance issue that you need to address. So solids can get over the weirs by increasing the water level in the tank. So that's something you can try to do with in operation without taking the system completely down. But you need to be very careful because you don't want to somehow overfill your tank and push water all the way out and sludge out into your biogas piping. So that's just got to be done with caution. So really, you can't go into this tank or really open it up while the system's live. You need to shut down because it's closed and it's got that gas space. So again, like what Jill was saying, you got to shut the system down, let the system go dormant so the gas production is minimal. You have to purge that space with inert gas. Then once the biogas H2S readings coming out of that space are below LEL, below permissible limits, then you can open these tanks and ventilate. And you pretty much got to keep it ventilated during an opening. And I mean, my experiences in other industries such as refining, those initial openings, you need to be very careful when you do that, even if you've inerted the space. Typically done in fresh air until you confirmed that the O2 is good, the LELs are good, the H2S is good. Inert gas is just as much of a hazard as H2S because it displaces oxygen. So opening of these vessels after inerting is still something that has to be taken very seriously and with proper safety review and procedures. So again, after you do all that, again, entry into the top is still a confined space. So after you've opened these things up, drained it out, and inerted everything, going in the bottom, you would see the internal feed distribution piping. So a lot of, over 30 years, our internal feed distribution pipes are different across all different plants. So this picture here is one example. You may not have this exact example in your plant, but they're all have the purpose of distributing the feed across the floor of the reactor. So there's orifices in these pipes, and those are small, so they can become clogged. So that's something to look at when you go in there. So if they are clogged orifices, that would lead to bad distribution. So again, that's something when you're in here, you want to make sure those orifices are clean, unclogged. If they're broken, fixing them so that you can get better performance when you start back up. How do you keep it clean? Well, you can screen the influent water. That's a static screen. You can use a static screen, a rotary screen. That's typically how we recommend screening our wastewaters. You can hydraulically purge the piping with a sludge bed mixing, a header check. Jill had already mentioned that. We can talk a little bit more about that in a minute. You can also clean the piping out with a high pressure jetting. So high pressure cleaning, this is an example of a procedure we developed of how to do it. It's not really easy, but technically you can do it with the system still in service. You don't have to take it fully down. You could also do this with the system out of service. That would be preferred because it's easier and you don't have to worry about the tank full of water. But essentially you take those feed headers, and if you connect a T on the end, you can then hook that T up to a bucket or a drain somewhere. And on the blind end of that flange, you can put a high pressure washer with some kind of O-ring seal and essentially extend a pressure washer in through that header while draining it down and kind of flushing that system out with the high pressure through the header and almost draining it back down into the bucket or drain. So, I mean, a couple of clients have used this procedure and it has worked. Ideally, you'd take the system down to do this, but I think some people have tried to do this and done it online. So we have piping and valves that allow the back end to be open. So just further down on, not shown on the drawing, you would have a valve on the other side of the tank. Say it's like a 6-inch on this side, it might be a 3-inch on the back side, and the pipe goes all the way through. You can, if it's completely clogged, you can open it on the one end, connect a power washer, and open the back end and kind of just push it through. And you can just, or you could just hook a hose up and flush a high volume of water through there. But again, make sure when you close the back end while the fire water hose is still being added, so the sludge doesn't back up into the header. So I think Jill mentioned that earlier, just making sure you don't back sludge into the feed header system too much, because that can cause clogging itself. Here's this hydraulic mixing, so header checks. So Jill has developed a lot of these procedures, so she may jump in and correct me if I'm saying anything wrong, but this is a way you can mix the sludge bed when the system is online. So here's a typical installation of a feed header distribution system. There are 2 pulsing valves. Those are those red automated valves kind of in the vertical, and there's 6 strings there. So what you can do here is put the reactor feed flow in manual, open the flow control valves, if there is one, to 100%, or set the VFD to a defined percentage. Open any bypass mixing valves, bypass anything else in the system. Say there's a heat exchanger or some other thing that's causing resistance. You want to flow through the system with the least amount of resistance and record everything with the flow open. So then after you have this system in the correct flow and everything open with the least resistance, you're going to close all but the first header and then record that flow rate on your flow meter for that one header. Then open the second header slowly. Again, doing this all slowly because you're putting more flow through the system. You don't want to hydraulically shock anything. Record and then open the second header, close the first header. So now you just have flow going through one header again. Record that flow. So you want to continue that step until each header flow has been recorded. And then open all the headers again, record the all open flow again. So after you've done this, you're going to put everything back in auto and stop bypassing anything such as a heat exchanger or any other piece of equipment in line. So this test you should have done really initially at startup when all the piping was known to be clear. So you should have a benchmark of what it was when everything was clean versus when you've just done this test and recorded it. So flow measure at that time was the reference flow, your benchmark. If the header flows are much less than that benchmark or the reference, then you are pretty much, or you're pretty sure you're starting to see some clogging in that header. So what you can try to do is try mixing again, try the header checks more often. Maybe those header checks clean it out and you see good flow, but then later it starts to deteriorate. You know, you might have to increase the frequency of these header checks. If all that doesn't work, then you can try that high pressure cleaning. If it gets so bad, you might have to go into the system, take it down, go into the system and really clean those headers out. But again, the key point here is never try to backflow the reactor water to clear the piping. So that only allows sludge to come back into the piping and clog the nozzles worse. Okay, again, safety again. When we start talking about biogas, Jill did a good job bringing up the safety issues, but again, remember, it's flammable, it's toxic, it has H2S in it, and H2S is toxic at low concentrations. And all your biogas equipment needs to be maintained, but you got to be sure you're being safe when you're maintaining it. So sediment trap, that's usually the first piece of equipment coming off your reactors. So biogas is saturated with water. You may also get foam in the system. So that sediment trap collects the condensate and foam so it doesn't impact the downstream equipment or block the lines. So just always make sure that thing is drained and clean. When you're down for maintenance, open it up, clean it out, things like that. Drip traps, the sediment trap gets out the most of the water, but as you have your piping along the system going to the flare, going to your biogas utilization, the boiler, whatever, you know, over the length of the lines, you're going to accumulate condensate. So you have to have these drip traps at low points or along certain lengths of pipe. So if you don't drain that water out along the piping, it'll build up, block the line, possibly cause gas blockages and pressure increases. So these drip traps are placed all along the lines, and they have to be drained. So check these things out, make sure they're working during operation, have it as a routine maintenance to go and drain these things. But when you're down for maintenance, also check and make sure these things are working properly and you can replace them. Back pressure valves, these are pretty critical pieces of equipment because they're the ones controlling the pressure on your reactors. So they typically have the diaphragm in there, so you need to make sure that diaphragm's in good shape. Make sure they don't become clogged with foam or water. So hopefully your drip traps and your sediment trap is doing its job. Some of these valves are automated valves, like a motorized electric or pneumatic valve with a PID control loop. So even if it's not this style mechanical valve with a diaphragm, just a automated valve, actuated valve still needs maintenance. You got to check that when you're down. Note of electrical classification. So make sure all your electrical equipment in areas of biogas is reviewed for class 1 div 1 or class 1 div 2 installation requirements. Typically seal offs are required. The right rated pieces of equipment, you know, NEMA 7 explosion proof things are needed in areas of biogas equipment. So always make sure that you have the proper electrical installation. PRVs, so these are very important pieces of equipment that always need to be maintained during operation and during times of downtime. So typically our systems run under, you know, 12 inches of back pressure. So these are very important pieces of equipment to prevent the system from being overpressured or damaged as far as with gas buildup, gas pressure buildup. Also vacuum relief. So these things ensure that when you lower the water level, that we don't cause a vacuum to be occurred in the tank or the piping system that would cause damage. So we always provide pressure and vacuum relief on tanks to prevent, you know, vacuum failures on tanks or the deck itself up there on the top. So regular maintenance, you know, typically most plants have at least a yearly requirement to maintain these vessels, but I think the OEMs usually recommend even more frequent maintenance. So there's gaskets on these pressure and vacuum relief sides that are just thin pieces of plastic. Those can wear over time. They can be damaged if the valve opens and shuts. So you could get leaking if the valve lifts and closes. So you got to be careful. One, they're delicate. Two, make sure that if you're replacing the weights or the gaskets, when you take the weights on and off, make sure you don't bend the gaskets or damage them. Most of our valves that we supply are Varic biogas, so make sure you look at their instructions and follow their instructions. Flame arresters, they are, again, like a backflash preventer, so they need to be kept clean. So don't let foam or scum or anything kind of get up in them. Check them regularly. Here, just as a note, if you have these flame arresters and PRVs in a cold climate, you better make sure they're heat traced and insulated, because condensation building up in there can cause freezing, and then you can't, your pressure relief valve's already been working. if those things are frozen. So check those, clean them regularly. They're pretty easy to clean. And typically we provide these systems with 2 PRVs. So you can isolate one, open up the flame arrestor, clean it, pull out that bag of plates, clean them out. They're usually aluminum, so you can't use a caustic cleaning solution. Typically, you got to use like just water or some kind of light cleaning solution, but just be careful that, again, there's a recommendation in the manufacturer's instructions of what type of cleaning solutions to use. You cannot use caustic because if they're aluminum, those things will be damaged by the caustic. Check valves, that's typically a key component in our system, keeping gas from flowing backwards in the line, or maybe air coming back in if you have a flare, open flare, or other piece of equipment. So again, make sure these things are clear. Typically, you can hear a opening and closing these valves during operation, so it's okay if you hear that clinking. But we've seen these things freeze, we've seen them get clogged, so it's a restriction. So you should check this during an outage. Flares, typically open flare or closed flare, the 2 kinds you can have. All usually have some way to automatically light the flare pilot should it go out, some kind of with a Venturi and spark igniter. Again, another form of backflash prevention, a thermal check. If you see here on the picture on the right, it's a vertical installation of a thermal shutoff and a flame arrestor. So if you ever got a backflash, that fuse would melt inside there and cause the valve to close. Then you would have that flame arrestor as well. So when you're down, it's important to check this fuse, make sure it's open, have some spare fuses, possibly replace these on some frequency. Again, always important to check this when you're down. So again, open flares, you can see that flame coming out of the top there. They use a Venturi to mix air and pilot gas with a spark plug to light it. So there's a thermocouple temperature in the pilot, which determines if flare's lit or not. You gotta keep that Venturi clean, make sure the regulators are working well, check and relight the system annually at least, probably even more, just to make sure that system is functioning properly. This system, again, is a Varic 1 picture. That's typically the manufacturer that we have supplied over the years. Closed flares, you can't see that flame easily. You kind of have to crouch down, get underneath it, look underneath it to see that flame. But they have very similar features. Again, if it's a Varic enclosed flare, they'll have very similar controls to the open flame flares. But again, you still got to look at that pilot line, make sure your spark plugs are working. If there's a Venturi system, make sure that's clean and working. Some systems have a blower assisted pilot, so you got to check that blower, make sure that blower is working. If the flare is temperature controlled here, make sure there's louvers are moving freely or in the right positions. So just in general, instrumentation as well is something you should be checking. It can fail or go out of calibration. So calibrating your instruments on some frequency during operation when you're down. pH is usually the biggest one you have to work on a lot. Those typically go out of calibration pretty easily. Preventive maintenance schedule for all your equipment, your pumps, your valves, your instrumentation, that's all very important. Is good to keep all that equipment from failing at inopportune time. Just one other item, it's not on the presentation, but your tank itself. If you have a bolted steel tank, epoxy coated or glass lined, when you're doing outages and you're inspecting your reactors, it's always important to look at the coatings because, coated systems do have a life. So when you're down for outages, inspecting those tanks and the coatings to make sure they're in good condition is very important to ensure you can continue to operate that tank and the reactor, settlers, internal piping for extended periods of time. You have a stainless tank, well, it's not as critical, but you should still be looking at those tanks, the conditions, looking for corrosion when you're there for an outage.
Okay, thanks, Jack. Thanks, Jill, for that technical presentation. I'm sure it's a perfect time for people as they're preparing their facilities for a potential outage for Christmas break. So hopefully it meant a lot for someone, and some people got some information that they may not have been aware of. Just want to remind everyone, there should be a question box on the right-hand side of your screen. If you have a question for one of our panelists, please feel free to enter it in there. We're going to try to get to as many of those as possible. And while people might be jotting some questions in that box, just want to remind everyone that we're going to try to have these about once every 3 or 4 months. So we're not sure exactly the date for our next quarterly webinar, but be on the lookout for an email similar to the one you got for this webinar, so you could sign up and share it with colleagues and make sure that you're there. Also, in the survey, I just wanted to let everyone know that there's a place in there. We want to hear topics that are important to you. So go ahead and write something in there if you want to get the panelists to maybe talk about some technical issue that you may be having some problems with, or just wanted to know how to remedy some issues. Would like to know that so we could plan accordingly. Okay, we have a couple of questions coming in. One question was, can I get a copy of the seminar to share with the staff? Yeah, absolutely. And by tomorrow, you'll actually get a link to watch that video, and you could share that with them. And also, if they register for the webinar with the email that you've registered with, they'll be able to watch this on demand as soon as they register for that. So, yeah, it is going to be archived and available for your teams to watch. Okay, switching to a technical question. And the question is how often should the entire reactor be emptied and drained and to do sort of a detailed deep dive inspection? So Jack, is that something you could answer?
Yeah, I mean, that's always a question we hear. I mean, I would say 5 years. You could probably go further than that if there's no problems. If you're a well-performing system, you're treating your wastewater, you're not losing sludge, you have no clogging issues, I would say 5 years is a typical time of doing a major outage, just to go in and look.
That's the way we would like them to do that, but I have to say a lot of our customers have never done it.
Right, yeah, agreed.
And then when they do, they find out they probably should have done it sooner.
Yeah.
So preventative maintenance is always better than surprises when the emergency comes.
Sort of a similar question with that is, what do most customers do when they drain the tank? Where do they store the sludge, and how do they sort of go through that process so they don't have to reseed it with new sludge?
Yeah, if there's a sludge holding tank you have on site that was originally provided, or you may have added, or like those tanks on wheels, the frac tanks, the Baker tanks, that brand, that you can get like a 20,000 gallon rectangular tank on wheels. One of our clients brings those, they do a shutdown, I think every 2 years, and they bring all those tanks on site, put all their sludge in those rental tanks, take the system, clean it out, and then pump it all back in.
Okay, another question we have here from someone, it's about the biogas equipment maintenance. And the question is can the weighted pressure and vacuum relief valves fall out of calibration? Do the weights ever change in mass, or this person's asking, can I save myself some money and time by just inspecting and replacing the gaskets themselves?
Yeah, so those weights are lead, usually lead discs that are calibrated to the weight required to make the right pressure setting that the valve was set for. So unless there's something corroding them, or maybe it's opening and closing and they're smashing down and you got chunks of lead coming off, that they shouldn't really be deteriorating that often. So
yeah, I've never heard of them going out of calibration in the 40 years that I've been there. You just have to be really careful when you're changing that gasket. You got to make sure you take the weights off. The weights are sitting on a pallet, and you got to take the weights off before you pull the pallet up to change the gasket.
Yep.
And as long as you do that, you should be good.
Okay, going back to the startup after there's been a shutdown, Jill, can you talk a little bit about, you said to start at a certain percentage of flow, whether it be 50% or 75%, depending on how long. Can you talk about what things you need to monitor before you start increasing flows?
Okay, good question. Yeah, you want to, my favorites always watch the volatile fatty acids in the effluent. And as long as they remain low, everybody knows they should be less than 5 milli equivalents per liter. The system is working well. I mean, everybody has their own background level of VFA that they run at. I'd like to see 0, but some people run at a consistent 2. So as long as you're below your normal operating level, at or below your normal operating level for at least, I'll say, a day or a shift, go ahead and then start to increase slowly until, you know, as long as the VFA is good and you're making good gas, the gas production's coming up as the load comes up, then you should be good and you can keep going up every, you know, I'll say every 12 to 24 hours. You can keep increasing.
Okay, another question that came in for the header checks, what percentage of flow loss necessitates some remediation efforts?
I say 10% difference.
Mm-hmm.
Do you agree with that, Jack?
Yeah.
So if your normal flow through a header is 1,000 gallons per minute, if you get down below 900, then yeah, something's probably not right. You probably got a clog somewhere in that line. It's really, if it's clogged, it's pretty evident. You know, the flow changes quite a bit.
And in that case, would you recommend doing some, not taking the unit offline and trying to clean those out, or would you recommend go ahead and pull the unit offline and drain it and doing some deep dive inspections?
I would say no, not unless it's really impacting performance. You would just try to keep it where it is and not let it get any worse.
Yeah, the other thing you got to watch is we didn't talk about, we talked about clogging, but I've also seen a case where the header breaks. In that case, you get a much higher flow. In that case, you probably do want to go in and fix it at that point. But if it's just clogged and your performance is good, like Jack said, don't if the reactor is running well, don't fix something that's not broken, even though you know it's broken.
Okay, another question here. It says, what do you recommend for low pressure gas readings on digester back pressure, a burden tube type gauge, or an open manometer that Varick sells from a maintenance and safety perspective?
I mean, we don't usually use those type of gauges anymore. We usually just have a regular pressure gauge and pressure transmitters as well. We want to have trended and digital signals. So manometers, we usually just use manometers when we're doing like testing, initial testing to pressure test the system, just to double check a pressure gauge. But I would say some type of Borden tube pressure gauge or a pressure transmitter are the best types of instruments for pressure readings.
That's what I was going to say too, Jack. Exactly. I mean, we usually use the manometers during the when we're checking out and doing the initial hydro and pressure testing on the tanks, because there's nothing more accurate if you want than a piece of tubing and some colored water in it. So you're pretty sure you know exactly where you're at.
Okay, another question is what are some of the leading indicators for when you might have to do a refurbishment to the reactor, such as a new settler? What kind of things should you look for?
Jill, you want to talk about the process indicators?
Well, yeah, I mean, yeah, I don't even think it's a process question. I think it's a more mechanical question, but
Okay.
I think that as long as the settler is gas tight, you're good. If you take it down and you look and you're seeing corrosion in it, or like they say, the levels are out of the levels, the weirs are out of level, that's something you want to take care of. You'll notice that usually settlers need to be maintained if you're losing sludge. I mean, remember that the purpose of the settler is to keep sludge in the reactor. So if you start to lose sludge, that's an indication that something's wrong with the settler and you need to look to see what that might be. And that could be because it's clogged or it's broken or it's not level. Any of those three could cause you problems. So that's when I would start to investigate what was wrong, when you start to see a sludge loss.
Mhm.
Or in an open tank, if you see gas bubbles coming out from it. I mean, that's going to tell you that something's broken in there.
Yep. So on the open top tanks, again, you can open those covers and look inside and see the weirs and see the troughs. That's all fiberglass. So those typically, again, that vapor space above the water level is still a slightly corrosive atmosphere. So that fiberglass, even though fiberglass is corrosion resistant, it will deteriorate over time. So depending on how much sulfur is in that water and coming out of solution and in that vapor space, your fiberglass could be deteriorating. So some plants, the fiberglass lasts for 30 years. Some plants, the fiberglass lasts for 10 years. So that's a item to put on your guys' list to check and see the quality of your fiberglass. Does it look like it's delaminating, cracking, breaking? And that should get replaced on sometimes 10 years, sometimes 15 to 20 years.
I was going to say, I think the minimum, like the 10-year is I don't think I've had anyone go bad at less than 10 years. So
right.
Around 9-10 years, you should start looking to check on it.
Another question here is how often and when is it required to have the system inspected by, I guess it would be us, the manufacturer?
Again, we don't require for us to inspect it as the original designer. If you're still in contact with your tank vendor who originally built the tank, they may have a recommended tank inspection frequency. So that may be something to look at. That's usually yearly or every certain number of years or whenever you can take the tank down. It's pretty open-ended. But we don't require that Veolia be on site on some frequency for inspections.
But if you want us to be on site for the normal, like Jack mentioned earlier, a normal 10-year or 5-year takedown,
Mm-hmm.
You can arrange with us to have somebody there for that, to inspect the settlers and stuff for you.
Yep. Yeah, we'd be happy to do that.
Rewinding back a little bit, talking about the sludge, we have a question here about it. So I think the asker was asking us, what happens to the dormant sludge beyond the magical 12-month period in the sludge holding tank? Does the activity sharply decline? Does it slowly decline over the time period after that? And also, does temperature such as freezing temps affect the sludge in terms of the shelf life of the sludge?
Yes, freezing will affect the shelf life. You don't want it to freeze. So a lot of our customers that have a sludge tank in the winter, they will actually rotate sludge in and out of the warm reactor into the sludge tank to keep it from freezing. There is no magic 1-year number. That's just a rule of thumb. It can last longer than that. And it's, there's no like, it's like if 367 days, it's going to drop off and never be able to be useful again. The longer it's down, the more activity will be lost. But everybody's sludge is different, so I can't give you a number that's saying, like I say, if 367 days, your activity will be 50% less. Like I say, everybody's is different because the storage conditions are different. As long as if the temperature is cooler but not freezing, it'll last even longer because the metabolism will slow down, and then it'll start to eat on itself if the temperature is warm. So if the temperature is cool, it won't eat on itself, and it'll be once it's warmed up again, it'll be ready to go.
All right, I think we got to all of the questions that were in the queue, so thank you for taking the time to write those questions. And then I just want to wrap up this webinar by first thanking our two panelists who are really busy right now and closing out the year. It meant a lot to come on here and share your knowledge with all the participants. I also want to thank all of the people that spent time learning a little bit more about these systems and how they could improve and do the best practices when they shut down and start up, and ensuring their maintenance items are addressed there. I just want to also offer, if there's any other issues, please don't hesitate to get in contact with us. We're here to help and support you and your system to make sure it's operating and optimized. So please just either send me or Jill or Jack an email. We'd love to talk a little bit more about that with you. And at this time, this concludes the webinar. I just want to wish everyone a happy 2021 and happy holidays, and wish the last couple of weeks of this year to be as best as possible for you. Thank you, and have a great day.